This is SpaceTime, Series 23, Episode 39, for broadcast on the 29th of April, 2020. Coming up on SpaceTime, the strongest evidence yet that neutrinos explain why the universe exists, a possible second planet detected orbiting Proxima Centauri, and Cheops begins its scientific mission. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
The difference between neutrinos and their antimatter counterparts may provide scientists with their best evidence yet to explain why the universe exists. When our universe came into existence 13.82 billion years ago, equal amounts of matter and antimatter were created. The problem is, when matter and antimatter meet, they annihilate each other, and so the universe should have exploded in a sudden flash of gamma-ray energy virtually as soon as it formed. But clearly it didn't, and despite all their efforts, scientists can't explain why. In fact, it's become one of those ultimate questions that humanity ponders. Why are we here? And then, if you're a scientist, the immediate follow-on question's gotta be, why do we live in a universe dominated by matter rather than antimatter? After all, the only difference between matter and antimatter is the charge. Or is it? The current laws of physics can't explain why matter persists over antimatter, why the universe is made of the stuff. The best physicists have been able to come up with is suggesting that there've got to be some sort of differences in the way matter and antimatter behave, which can explain why matter's persisted and now dominates the universe. Now, new data has thrown more support behind the hypothesis that neutrinos are the reason the universe is dominated by matter. See, every particle of matter has an antimatter equivalent, and neutrinos are no different, with an antimatter equivalent called the antineutrino. They should be exact opposites in their properties and behaviour, which is what makes them annihilate each other on contact. But now, a report in the journal Nature claims an international team of researchers, which make up the T2K collaboration, have found the strongest evidence yet that neutrinos and antineutrinos behave differently, and therefore may not wipe each other out. One of the study's authors, Patrick Dune from Imperial College London, says the findings bring science closer than ever before to answering that fundamental question of why matter exists in the universe. If confirmed, and Dune says at the moment he's over 95% sure, it'll have profound implications for physics and should point the way to a better understanding of how the universe evolved. Previously, scientists have found differences in the behaviour between matter and antimatter versions of subatomic particles called quarks. But the differences observed so far in quarks don't seem to be anywhere near large enough to account for the dominance of matter in the universe. However, T2K's new results indicate the differences in the behaviour of neutrinos and antineutrinos appear to be quite large. Like quarks, neutrinos are fundamental particles. But unlike quarks, which make up pretty well everything, neutrinos are very weakly interactive with normal matter. In fact, they're so weakly interactive that around 50 trillion neutrinos from the Sun are passing through your body right now, without you even noticing them. Neutrinos and their antineutrino counterparts each come in three types or flavours, known as electrons, muons and taus. As they travel, they can oscillate or change from one flavour to another. Evidence that muon neutrinos oscillate into electron neutrinos was first discovered by the T2K experiment back in 2013. To get the new result, the authors fired beams of muon neutrinos and antineutrinos from the J Park facility at Tokai in Japan, and detected how many electron neutrinos and antineutrinos arrived at the Super Kamiokande detector 295 kilometres away. They looked for differences in how the neutrinos and antineutrinos change flavour, finding that neutrinos appear to be far more likely to change than antineutrinos. Now, the new results aren't the complete answer yet, but they're a big step towards finding that answer. And of course, there are still many more questions about these strange elemental particles that need to be answered in order to get the full picture, such as what are the real masses of the different flavoured neutrinos? In fact, do they all have mass? And what about the mind-blowing idea that neutrinos may actually be their own antiparticles? This is SpaceTime. Still to come, astronomers pick up some tantalizing clues about the possibility of a second planet orbiting Proxima Centauri, our nearest neighbouring star system. And the European Space Agency's Cheops mission successfully completes 3 months of in-orbit commissioning and is now ready to begin its science mission. All that and much more still to come on SpaceTime. Astronomers have received some tantalizing clues about a possible second planet orbiting Proxima Centauri, our nearest neighbouring star system. A report in the journal Astronomy and Astrophysics and on the pre-press physics website archive.org claims that a signal, possibly from a potential new exoplanetary candidate Proxima C, has been picked up using the Doppler shift radial velocity or wobble method. The Doppler shift radial velocity method uses the detection of an ever so slight wobble in a host star caused by the gravity of an orbiting planet. Proxima Centauri is a spectral type M red dwarf star with about 1/7 the diameter and about 1/8 the mass of the Sun, located some 4.23 light-years away. It's part of the Alpha Centauri triple star system, orbiting the 2 other stars in the system, Alpha Centauri A and B, at an average distance of about 0.21 light-years. Scientists have long speculated about the possibility of other planets orbiting Proxima Centauri, ever since the 2016 discovery of the first planet, Proxima b, our nearest exoplanetary neighbour. That confirmation was made by astronomers using the European Southern Observatory in Chile, also employing the wobble method. Proxima b has about 1.3 times the mass of the Earth, and it orbits Proxima Centauri at an average distance of just 0.05 astronomical units. That's about 7.5 million kilometres, which is in the habitable zone, the region around a star where temperatures would allow liquid water, essential for life as we know it, to pool on the surface of a terrestrial planet. By the way, an astronomical unit is the average distance between the Earth and the Sun, about 150 million kilometres or 8.3 light minutes. The first hints of a possible second planet orbiting Proxima Centauri surfaced in radial velocity observations taken in January from the Astrophysical Observatory of Turin by astronomer Mario Damaso. But that data wasn't clear enough for any firm confirmation. It seems to suggest a second planet much further out than Proxima b, possibly around 1.48 astronomical units. So Damaso, together with fellow astronomer Rafael Grattan from the Astronomical Observatory at Padova, decided to search for more evidence by looking through the 4-year SPHERE Infrared Survey for Exoplanets, or SHINE dataset. SHINE used the European Southern Observatory's Very Large Telescope SPHERE, or Spectropolarimetric High Contrast Exoplanet Research Instrument, to hunt for exoplanets. The authors attempted to separate out the faint hints of a signal from a planet from all the noise of the background stars. And as they did so, they kept getting the same speck, not enough for a planetary detection, but also unlikely to be caused by simply random noise alone. Now, if the speck is a planet, it's somewhere around 7.2 to 8.6 times the mass of the Earth, so it's a super-Earth, depending on how the data is interpreted. Also, this planet may well have a ring system similar to that of Saturn. But as well as being hard to pin down, the data has another problem, and it's quite a big one. You see, the study assumes the presence of a dust disk around Proxima Centauri, and the problem there is observations using ALMA, the Atacama Large Millimetre Submillimetre Array Telescope, doesn't show any evidence of any such dust disk in the system. So, I guess that means more observations will be needed to either confirm or finally rule out the planet's presence. Either way, we'll keep you informed. This is SpaceTime. Still to come, Cheops begins its science mission, and the Expedition 62 crew return home, but to a very different world from the one they left. All that and much more still to come on SpaceTime. Okay, let's take a break from our show for a word from our sponsor, ExpressVPN, rated #1 by TechRadar. You may be wondering why you need a virtual private network. Well, it's in the name. It's all about privacy. Do you really want big brother tech companies, hackers, governments, and who knows who else snooping in on your online activities? Now, you might not have anything to hide, but it's still really creepy, and it could be dangerous for you and those you care about. Also, how often do you run across a website and you want to get information from it, but you find out that they're geo-blocked? It's all very frustrating, and it's becoming an increasing problem. And that's where ExpressVPN can help you. ExpressVPN's a simple and efficient way to protect your online privacy. It's internet without borders from the world's leading VPN provider. So, protect your online privacy today and find out how you can get 3 months free at tryexpressvpn.com/space. That's tryexpressvpn.com/space for 3 months free with a 1-year package. Visit tryexpressvpn.com/space to learn more. And of course, you'll find the link details in the show notes and on our website. That's tryexpressvpn.com/space. And now, it's back to our show.
You're listening to SpaceTime with Stuart Gary.
The European Space Agency's exoplanetary mission Cheops has successfully completed 3 months of in-orbit commissioning and is now ready to begin its science mission. Cheops project manager Nicola Rando says the spacecraft's now undertaking observations of known exoplanet-hosting stars. Cheops, which stands for Characterizing Exoplanet Satellite, was launched back in December 2019 on a mission to study planets orbiting stars beyond our solar system, and then accurately determine their size by studying how much light they block out from their host stars as they pass or transit in front of the star, as seen from Cheops' position. Accurately knowing their size, together with their orbital distance from their host star by their gravitational impact on that star, will tell astronomers about their density, and from that their possible composition, as well as constraints on their structure, formation and evolution. But before any of that can be accomplished, mission managers first needed to ensure the 1.5-metre spacecraft survived its violent launch into space and that all its delicate scientific instruments are working properly. Cheops' orbital commissioning and testing began when it first opened its eyes to the universe at the end of January, and shortly after that took its first intentionally blurred images of stars. The deliberate defocusing is at the core of the mission's observing strategy, which improves measurement precision by spreading the light coming from distant stars over multiple pixels in the detector. Following initial in-orbit systems checks in January and February, mission managers then began analysing the response of the spacecraft, and in particular of the telescope and detector in the actual space environment in March, focusing on stars whose properties were already well known. These acted as sort of controls to ensure that Cheops' photometric observations were accurate and the satellite was precise and stable. During the final 2 weeks of in-orbit commissioning, Cheops observed 2 exoplanet-hosting stars as the planets transited in front of their host stars and blocked out a fraction of the starlight. One of the targets was HD 93396, a yellow subgiant star located 320 light-years away, slightly cooler and about 3 times larger than our Sun. The focus of the observations was Celt 11b, a puffy gas giant planet about 30% larger in size than Jupiter, which is in a much closer orbit to its host star than Mercury is to the Sun. And the light curve from this star showed a clear dip caused by the 8-hour-long transit of Celt 11b. Now, from these data, scientists have been able to determine very precisely the diameter of the planet to be 181,600 kilometres, and that's with an uncertainty of less than 4,300 kilometres, about 5 times better than any previous measurements from Earth. Astronomers have now started observing a selection of early science targets, including the hot super-Earth 55 Cancri e, which is covered in a lava ocean, as well as the warm Neptune GJ 436b, which is losing its atmosphere due to the glare of its host star. And then there's a white dwarf it's going to check out with a surviving planetary system. This report from ESA TV.
ESA's first dedicated mission to study exoplanets, Cheops, launched in December and is about to start its science operations. During the last few months, Cheops successfully completed its in-orbit commissioning phase, and the spacecraft, telescope's optics, detectors and electronics were all working as expected. The Cheops telescope opened its cover in January and in February targeted its first star, around 150 light-years away in the Cancer constellation. The triangular shape is due to the 3 struts supporting the telescope's primary mirror. It's also deliberately out of focus because the star's light is spread across many pixels to make the measurements more precise. Cheops will soon start observing hundreds of stars outside our solar system that are known to have orbiting planets. It will measure the minute dip in light caused by exoplanets as they transit a star. Cheops is a small or S-class mission. It was developed by ESA in cooperation with Switzerland within budget and in less than 5 years, and built by a consortium led by the University of Bern. The instrument team in Bern works closely with the Science Operations Centre at the Geneva Observatory. This is where commands are prepared for the spacecraft and where data is downlinked and analysed and processed. The Mission Operations Centre for Cheops at the National Institute of Aerospace Technology site near Madrid sends these commands. It operates and monitors the spacecraft and ensures that the telescope's data flows smoothly to Geneva. The observatory is also where scientists discovered the first exoplanet in 1995. Today, there are over 4,000. Cheops will observe hundreds of exoplanets that range from rocky and possibly Earth-like to gaseous ones like Jupiter. Its precision measurements will be key to understanding their inner structure, formation and evolution. Scientists from institutes that have contributed to the Cheops mission have GTOs, Guaranteed Time Observations. There's also a guest observer programme for researchers worldwide. The science mission continues until October 2023 and will expand our understanding of exoplanets and the universe we live in.
Three Expedition 62 crew members have returned safely to Earth following their 7-month stay aboard the International Space Station. The crew's Soyuz MS-15 capsule touched down under the canopy of a giant orange and white parachute on the Kazakhstan steppe 4 hours and 26 minutes after undocking from the orbiting outpost. But the crew have arrived home on a very different planet compared to the one they departed from, with lockdowns and an economy in recession dominating the planet in the wake of the COVID-19 coronavirus pandemic. Traditionally, crew returning to Earth aboard Soyuz are extracted from the capsules and undergo preliminary medical checks and a welcome home ceremony in a tent on the ground right next to the spacecraft. However, the COVID-19 outbreak has resulted in a change of program, with the crew immediately airlifted by helicopter to Baikonur, from where they then boarded their respective aircraft, taking them either to Star City, Moscow, or direct to Houston, Texas. How times have changed. This is SpaceTime. Coming up next, the Science Report and growing calls for an independent investigation into the COVID-19 pandemic, and the new gene editing approach which can attack 90% of coronaviruses, including COVID-19. All that and more still to come on SpaceTime. And time now to take another brief look at some of the other stories making news in science this week with a Science Report. China's Communist government and the World Health Organization have both issued statements saying the COVID-19 virus wasn't created in a laboratory. Their statements follow growing international calls, including from the Australian government, for an independent investigation into the origin and spread of the pandemic. But what makes Beijing's statement and that of the World Health Organization so interesting is that their denial that the virus was developed in the Wuhan Biology Research Center wasn't the allegation being made. The actual allegation is that the virus was being studied at the research center and that it accidentally leaked out into the surrounding community due to poor biohazard security and control at the Level 4 research facility. The claims are based on 2 United States intelligence and national security reports, which found that China instigated tighter security protocols at the facility at exactly the same time as the first Wuhan patients were presenting with COVID-19, and that China then prevented people from Wuhan from travelling to other parts of China, but didn't impose similar restrictions on people travelling from Wuhan to other parts of the world. US President Donald Trump has now ordered a full investigation into the matter. Meanwhile, the Washington Post is reporting that US Embassy officials who visited the Wuhan Institute of Virology facility in 2018 warned of inadequate safety at the lab, which was conducting risky studies on coronaviruses from horseshoe bats. The Post reports that researchers showed how the coronaviruses can interact with ACE2 human receptors, allowing the transmission of SARS-like coronaviruses from bats to humans. Scientists have developed a new gene editing approach which can attack 90% of coronaviruses, including COVID-19. Called Pac-Man, which stands for prophylactic antiviral CRISPR in human cells, the approach slices through the virus's genetic makeup, stopping it from functioning and replicating. However, the technology reported in the journal Cell is still in the proof of concept stage, with the biggest barrier being the safe use of Pac-Man in the human body. A new study says regular use of aspirin, defined as taking at least 1 or 2 tablets a week, is associated with a significant reduction in the risk of developing cancers in the digestive tract. The research, reported in the Annals of Oncology, canvassed evidence from 113 observational studies, finding those who took aspirin had a 27% reduced risk of bowel cancer, a 33% reduced risk of esophageal cancer, a 36% reduced risk of stomach cancer, and a 22% reduced risk of pancreatic cancer. However, the researchers urge caution, saying the drug should only be taken for this purpose in consultation with a doctor who can weigh up the risks of side effects. A new study has found that estuaries on the southeast coast of Australia are now warming at twice the rate of oceans in the atmosphere. The findings, reported in the journal Nature Communications, warns that the apparent accelerated impact from climate change on estuaries could adversely affect economic activity as well as ecological biodiversity in rivers and lakes worldwide. Scientists from the University of Sydney who carried out the research say that it shows estuaries are especially vulnerable to a warming environment. The researchers say changes in estuarine temperature, acidity and salinity affect marine and bird life, as well as the millions of people who depend on rivers, lakes and lagoons. Scientists found that on average estuary systems experienced a 2.16 degree temperature increase. That's about 0.2 degrees each year. The findings are based on 12 years, recording more than 6,200 temperature observations in 166 estuaries along the entire 1,100-kilometre stretch of the New South Wales Pacific Ocean coastline. The increase in temperature is an order of magnitude faster than predicted by global ocean and atmospheric models. According to the Australian Bureau of Meteorology, air and sea temperatures in Australia have increased by about a degree since 1910. The study also found that acidification of estuaries was increasing by 0.09 pH units every year. And there were also notable changes to the salinity of estuary systems, with creeks and lagoons becoming less saline while river salinity increased. A team of Australian scientists believe they've developed a way to address a decades-long challenge in the field of quantum materials, namely the spectral tuning of proposed quantum light sources. They say the results, using anatomically thin material, constitute a significant step forward in understanding light-matter interactions of quantum systems in two-dimensional materials. It also moves forward the journey towards scalable on-chip devices for quantum technologies. You can read the study in full in the journal Advanced Materials. And that's the show for now. SpaceTime is broadcast on Science Zone Radio by the National Science Foundation in Washington, D.C., and through both iHeartRadio and on TuneIn Radio. Or you can subscribe and download SpaceTime as a free podcast through Apple, Stitcher, Bytes.com, Pocket Casts, SoundCloud, Spotify, YouTube, Audio Boom, Podbeam, Android, Castbox, from SpaceTimeWithStuartGary.com, or from your favorite download podcast provider. You can help support the show and the work we do by visiting the SpaceTime online shop and grabbing yourself a few goodies, or by becoming a SpaceTime patron, which gives you access to commercial-free double-episode versions of the show, as well as bonus audio content and other rewards. Just go to our Patreon page through SpaceTimeWithStuartGary.com for all the details. If you want more space time, check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as loads of images, news stories, videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word and in lowercase, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, at SpaceTime with Stuart Gary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to www.facebook.com/spacetime with Stuart Gary. SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.